So the first video that we looked at, or last video we looked at, was more like, grade 11 physics, math type stuff review, the trigonometry, some basic algebra, some graphing stuff, tangents on curves. These are all like mathish type stuff that we did in grade 11 and we practiced in grade 11, then we applied in grade 11, that type of stuff. The trig and Pythagoras kick in with the vectors. There's lots of graphing and that type of stuff. So we're also going to look at some other types of math aspects that are more relevant to grade 12 physics. Not that the other ones, we're going to use all the other ones as well, but just a little different mindset. You guys are a little bit older. You guys have done some more stuff, and just some of the math stuff that kicks in for grade 12 physics that's also really, really important for what we do. So like underlying math ideas, principles that sort of kick in every now and then. So let's look at some math. Basically some math stuff for good old-fashioned 12 physics. There's just a couple basic things that we are going to look at. Now, one of the basic things is, well, basically, it's based on algebra, and more specifically, it has to do with when we combine formulas. And we do, of course, use a lot of formulas for lots of different stuff, and we often have to combine formulas. Not always, but we will often combine formulas. So just take something really, really simple. For example, something like suppose you got like a is equal to 3b squared, and you've got c is equal to 8a over d squared. Okay, so maybe you have these two formulas. We're just making up a couple formulas here, and we want to combine them. Now, why would we combine? Well, there's different reasons why you would actually want to combine formulas. One thing that it actually does is it actually makes or can show new relationships between variables. For example, if I just look at these two formulas and ask, what's the connection between C and B? Well, with just these two formulas, there isn't one. So if I actually combine them, I can actually see if I can get the two in the same expression. So sometimes what you do is you can see new relationships out of it. Sometimes what you're able to do is you're actually able to cancel a variable out, which will actually show that the variable actually had nothing to do with the situation, or it wasn't needed, or maybe it's an unknown and you can cancel it out and then you don't have to worry about it because you didn't even have to know the value to actually solve for it. So there's different things that can actually come out of it. So you can get new relationships out of it. You can actually cancel variables and stuff like that. You can often make things more efficient. With just one combined expression instead of multiple expressions, it can often make things more efficient. And also, you can also become more accurate. So, for example, suppose you do a calculation, you do another calculation, you do another calculation. So you've done like 3 calculations, and if you round off and all that kind of stuff, by the time you get to the end, your answer's got a little more variance. But if you were able to combine the expressions and do it in one calculation, typically your answers are going to be more consistent, more accurate, and that type of thing. So, I mean, the biggest things for us will be the first two, being able to see new connections between variables and be able to cancel things out in order to, make things easier, more efficient, but cancel things out when we don't need them to show they're not actually relevant to the situation. So these are some of the reasons we often like to combine formulas, and especially as you do more and more like physics, engineering, chemistry, whatever you want, these last two, being more efficient and more accurate, really, really, really kick in nicely. And it just really ties things up and makes things a lot tighter. Okay, so if we wanted to combine these two things, there's basically 2 ways you can actually do it, and this actually kicks back to probably grade 10 math when you're combining 2 equations and you're using things like elimination. That's the reason you guys are like canceling out variables and putting equations together in math and stuff. That is to get to this type of stuff. Now, one way people will do it is they will just flat out just use substitution. For example, you've got a is equal to 3b squared. And you can take that 3b squared and you could substitute in for the a value right here. So you could rewrite this as c is equal to 8 3b squared over d squared. And you could do something like this. And just with this alone, you now have a connection between C and B that you didn't have before. Now, of course, you might want to simplify or whatever, that's fine. So, if we simplify this, would this be, 24 b squared over d squared, blah, blah, blah. Sometimes you'll simplify, sometimes you won't. It depends on what you want to do with it. It's not super critical all the time, but whatever. So this is a perfect example where it definitely shows a new relationship because now we've connected C and B together where we didn't before. Now, of course, another way people often do it is they'll equate them. So, you look for a common thing. What do they have in common? And the only thing these guys have in common is A. So, one is solved for A already. So A is equal to 3B squared. We'd rearrange this one for A, and A would be equal to CD squared over 8. So, you find the common variable. What do they have in common? Solve for it and then tie the two together. So you'd have 3b squared must then be equal to cd squared over 8. And then you can manipulate this and move it around any way you want, and you're going to end up with literally the exact same thing before. Like, you'll end up with this once you simplify it, and it doesn't really matter. Some people like to substitute, some people like to equate. I go back and forth depending on the setups and what I see in the algebra when I visualize the situation, but it doesn't really matter. You'll end up with the same thing anyway. So this is a really common thing that we'll do a lot of time, and sometimes we'll be able to cancel things out, sometimes we won't, but it really shows the new relationship, shows how one thing connects to another. And I mean, the more you do this type of stuff, whether it's in physics or chemistry, engineering, they do start backing away from the numbers more and more. It's more about the expressions and how seeing one variable connects to another variable. And that really kicks in. And a lot of times, especially when I took my higher level physics, there were no actual numbers or calculations. It was all about manipulating expressions, tying expressions together, seeing which variables are important, which one's the most important, which one's the least important, what'll have the biggest effect in the expression. If you change this value, how much will it change that value? That type of thing, not the actual numbers themselves. So this is just, this is basic algebra. This is really grade 9, grade 10 math. There's nothing fancy about it. It's just a different application or way to look at it and how to relate to some expressions that we'll be using in physics. Okay, so this is one little math type thing that we're going to be doing a little bit of. Now, sort of like the exact opposite of this, pretty much. We're going to get rid of all this type of stuff here. We'll delete this here. Pretty much the exact opposite of this, because that's particularly pretty specific and pretty accurate and pretty consistent. We also have to go the opposite way for what we're doing and look at estimating. And often when you guys do grade 11 stuff, I'd often, estimate your answers, approximate what your answers could be. So when you get the answer, you have an idea, is it way off? Is it close? That type of stuff. So estimating is also really, really important for us for what we do. Now, the thing that kicks in for, especially the stuff we'll do later on, it can be really, really, really hard to have an idea if you're right or not, especially when like subatomic physics type stuff. It can be really, really hard. Like when you're estimating like how fast a car is going and you get, like 18 meters per second, there's nothing wrong with that. And if you got like 14 billion meters per second, that's terrible. But like for subatomic stuff and some of like the planet stuff and gravity and a whole bunch of the weird stuff that we can actually do, actually being able to recognize if an answer is right or not can be really, really, really difficult unless you really, really know what you're doing. And even then it can be really challenging. So estimating also kicks in. So for example, what if we had something like this, like 7.6 times 10 to the 14 times 3.9 times 10 to the 12. And I asked you to estimate this. Well, the first thing you might do is, like 7.0, that's close to 8. 3.9 is close to 4. 8 times 4 is 32. But you're totally focusing on the wrong part. When you get 7.6 times 10 to the 14, the most important part about that entire thing is this right here. That is the most important part. Same thing for this one. That's the most important part right there. And when you're estimating something like this, forget about this. It doesn't matter. All we're trying to do is get a general idea of what our answer is going to be. So the fact that we might have something like a 32 out front is irrelevant. That 10 to the 14 and 10 to the 12 gives me a way better idea of where my answer is going to be. So forget the little first parts there. Worry about the powers 10. 10 to the 14 times 10 to the 12. basic grade 9 exponent rules, approximately equal to, is 10 to the 26. That's it. There's my estimate. This is what is called, when you're looking at this, this, and this is what's called looking at the order of magnitude. That's what that's called. And this is a great way to estimate answers when you're doing especially more elaborate calculations. All I want is a general idea where my answer is going to be. So I multiply this. I should get something, blah, 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 times 10 to the 26, 24, 27, 25, somewhere around there, but probably 26, maybe 27 or 25, 24, we'll see, but somewhere around there. So when I calculate this and I get, my final answer is 5.2 times 10 to the 4, I know I'm wrong. There's no way a 10 to the 14, 10 to the 12 multiplied together is going to give me a 10 to the, there's no way. So I know my answer is going to be around 10 to the 26. Okay, same thing if we had something like 8.4 times 10 to the 20 divided by 14.6 times 10 to the negative 18, and I want to estimate this. Forget the 8.4, forget the 14, it doesn't matter, it's irrelevant. All I want is a quick estimate. So I'm going to look at the 10 to the 20, I'm going to look at the 10 to the negative 18. That's it. Basic exponent rules, power of 20 divided by power of negative 18, subtract the 2, subtract the negative 18, blah, blah, blah. I'm going to get an answer somewhere around 10 to the 38. That's it. So I know when I calculate this out, I should say blah, 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 times 10 to maybe 37, 38, 39, somewhere around there, and I know I'm probably going to be right. Okay? Now, where this really, really kicks in, and I'm going to give you an example here. This is legitimately one of the calculations or types of calculations you'll be doing this year for sure, is something that looks like this. 9 times 10 to the 9 times 4.6 times 10 to the negative 14 times 5.2 times 10 to the negative 16, and we'll divide that by 3.4 times 10 to the negative 7 squared. This is legitimate, easily one of the calculations you'll do a cajillion times, something very similar. So to estimate this with all those coefficients in front, no point, don't even bother. It's all about the powers of 10. That's all it's about. And we can even break this down a little bit. If I look at the powers 10 on the top, the negative 16 and the negative 14, there's my negative 30. Negative 30 plus this, so I got like negative 21, so I got like basically negative 21 on the top. The bottom, I got the negative 7 squared, that's negative 14, so like 10 to the negative 14 on the bottom. So I've got 10 to the negative 21 divided by this, so subtract the negative 14 from the exponent, and we're looking around 10 to the power of negative 7. Okay, so when I'm all done my calculation, I should get a value of blah, 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 blah times 10 to the negative 7. Or at least really close to 10 to the negative 7. And if you actually calculate this out, you will actually get an answer at 10 to the negative 6, which I can see is really close to my negative 7. So I know I'm almost guaranteed I'm going to be right. Now, my coefficient in front might be wrong, whatever, blah, 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 but at least I know that my answer is around the 1 millionths, somewhere in there, and that's all that's important. So when I, calculate this out, and maybe you got, 4.2 times 10 to the 6, well, that's a total possible answer, just for this type of calc, could totally happen. But if I do a quick, 9, negative 14, negative 21, divided by negative 14, so around negative 7, I got positive, I know something's wrong. And it could be just, missed a negative in the calculation. It could be something that simple, it could be something else. But this is where this type of stuff really kicks in. Especially when you get to like multiple choice questions in exams, especially university, where they'll have the calculation that you have to do, blah blah. You got your options, and the options often sometimes can vary just by powers of 10 or whatever. You have a huge variation of answers. You do something like this, find that answer. If there's only one that's even close to 10 to the negative 6, that has to be the answer. You don't even actually have to do the rest of the calculation. So skills like this can really kick in and come in really handy in order to estimate your answers, have an idea where your answers should lie and that type of stuff. It really kicks in really well, especially when the calculations get bigger like this and you're doing it like 3, 4, 5 times in one question. Like it can really kick in. The other thing that comes in handy with this type of stuff, if you do this type of thing multiple times and you're doing it like 2 or 3 times for the same question with a very similar calculation, and you get what one of your answers is blah 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 times 10 to the 4, and you do another one and blah blah is you got times 10 to the 5, and then you got blah blah and you get times 10 to the negative 2. Your orders of magnitude are similar for the first two, but this guy right here, it's not matching up. So there's a really good chance that you've messed up this calculation right here. So it's like, hey, wait a minute, power, I've got, to the 10,000, I've got 100,000, I've got like to negative 2. There's a good chance you screwed up this calculation. So you go back, hey, I'm going to go check that calculation. And then, hey, it's still right. Well, maybe I need to check those 2 calculations because those 2 powers 10s are off. So not only can it be really good for estimating, but it can also be good for comparing your answers and checking work at the end to make sure, hey, all these answers should be about the same order of magnitude. Well, one of them's kind of off. Maybe I should just recheck that calculation. So stuff like this also really comes in handy by doing order of magnitude type estimation. So you've got the solving part with the equations and algebra and manipulating things to get rid of stuff and seeing new connections and all that kind of stuff. And then you've also got this where the estimating with the order of magnitude can really come in handy, especially when you're calculating stuff that approximate answers aren't going to be that obvious when you're not doing like everyday type calculations. Okay, so both these ideas will just keep popping up through the course, and you guys will apply them on your own, and I'll bring it up myself, but it's just great little things to really come in handy, little skill set in your little physics math toolbox that can come in handy on occasion.